Hello, my name is Noah, and today I will be going over my AERO4842 final presentation. I will be going over the mission objective and the many different functions of the scientific instrument. Mission objective. We were tasked with designing a scientific instrument that will be sent to the moon of Europa. I chose to develop a subsurface object detection and mapping vehicle device. The device will study the subsurface composition and terrain of the distant moon, and the detection and mapping device will also include many navigational techniques. How did I use this? In terms of hardware, I used the Arduino Uno R3 starter kit, which includes many different hardware pieces. For software, I used Arduino IDE and Python, and the chassis, a collection of different items. The chassis was inspired by a pontoon boat. This was done using styrofoam boards, cardboard, glue, propeller fans, and ball pins. The following video demonstrates the vehicle trying to propel forward on land. Detection and mapping. The detection and mapping was divided into two iterations, a non-water surface and a water surface. The following video demonstrates the vehicle propelling forward in the water while the detecting and mapping progresses. As you can see, the sensor is swinging left to right, detecting and mapping its terrain. The first iteration will demonstrate the detection mapping capabilities of the vehicle while mapping a non-water terrain. The terrain was simulated by two televisions with broomsticks going across for the vehicle to propel forward. The results are shown on the right. The first iteration was a success in terms of its mapping and detection capabilities. The second iteration will demonstrate the detection mapping capabilities of the vehicle on a water terrain. The terrain is simulated on the left by a box filled with about a foot of water, and as you can see on the right, this iteration was not successful. For the first navigational feature of the vehicle, it is instructed to perform a set series of instructions when confronted with an obstacle. The current configuration is set that when the vehicle detects an object within 3 centimeters, the motors stop. The right motor is activated for 3 seconds to perform a 90-degree turn. Both motors resume normal activity, and then the right motor is activated to turn the vehicle back in the normal direction. The following video demonstrates the obstruction avoidance in action. As you can see, both propellers are spinning, and when confronted with an obstacle, a hand, they stop. The one motor turns on, both motors turn on, the last one turns on, and then they both resume normal action. The second navigational feature of this vehicle is the direct operation. The purpose of this functionality is in case of blockage. It allows for direct operation of the vehicle to perform maneuvers. This is done using a small controller where each key press has a different functionality listed below. The following video will demonstrate a direct operation in action. In the video, the volume button is pressed to begin both motors' operation, and then the power button is clicked to activate the right motor, and then the function stop button is clicked to activate the left motor. The motors are instructed to stop after 2 seconds, so slight movements can be made. The last functionality of the vehicle is the humidity and temperature sensor. This is in order to study the temperatures on the distant planet or to provide a hibernation clause for the vehicle. The humidity and temperature sensor is instructed to return a temperature and humidity values every 100 milliseconds or to hibernate if the temperature reaches below 0 degrees Celsius or the humidity is above 90% water saturation. Takeaways. The vehicle is a success in terms of its navigational features, and it's also a success in terms of its ability to detect and map terrain, although not in water.